Hi everyone, myself Saranya, Assistant Professor from SNS College of Allied Health Science. Today we are going to see a topic on perfusion, flow and pressures. So why does the flow and pressure matters in perfusion? So as a perfusionist, we are doing a complex cardiac surgeries which require temporary circulatory support. And CPB replaces the heart and lung function during a surgical intervention. The understanding about it is you want to maintain an adequate perfusion, maintaining an organ viability. Why? Because as a perfusionist, we are giving a flows to the patient as we are taking over the function of both the organs. What could be the challenge that we can expect is balance between the flow and pressure. Maintaining that is also a major factor by the perfusionist. So actually what is flow, pressure and resistance is about? We can go into a physics of it. Flow is equal to pressure difference by resistance. As of Ohm's law for hemodynamics, he stated that the volume of blood moving through the vessel, and he also say about the pressure differences of mean arterial pressure gradient driving circulation and the resistance, opposition to the flow from the vessel walls and the viscosity. The electrical current is equal to voltage by resistance as of Ohm's law. So what is the importance of a perfusionist to take over the pressure and resistance mechanism is to maintain a mean arterial pressure of 70 to 100 mmHg during cardiopulmonary bypass. Although there are several factors which can influence these to not be occurred. The influencing factors are maintaining an anesthetic level, sedations and so on. So that leads to a decreased mean arterial pressure. If you reduce the flows, automatically the pressure can also get reduced. So maintaining a flow is actually depends upon how we get a drainage from the patient. So maintaining a mean arterial pressure of more than 70 mmHg will reduce the risk of organ hypoperfusion. The systemic vascular resistance is nothing but which decreases during CPB due to loss of a pulsatile flow as we are giving a continuous flow on bypass. The hypothermia and hemodilution also reduces the resistance. This can happen at the time of cardiopulmonary bypass. So maintaining a proper mean arterial pressure will depend on the pump flow rate. So maintaining a proper pump flow rate is an essential factor to maintain a mean arterial pressure. So what could be the ideal optimal perfusion flow rates that you can give on bypass? The standard flow rates will depend upon the cardiac index. 2.0 to 2.5 liter per minute per meter square of cardiac index is essential for giving a proper flow to the patient. When you reduce the flows below 1.2 liter per minute per meter square, which is moderate hypothermia, and in deep hypothermia you can go with 0.5 to 1.5 liters per minute per meter square. I am mentioning that actually this is in case of hypothermia. If you are not going into an hypothermia, reducing a cardiac index will drastically reduce your flow rates, and this will impact the perfusion of the patient, and their organ can get mismatched tissue perfusion ratio, and this can lead to an decreased flow rates, and organ failure can occur at the end of the procedure. Clinical decision makings or flow rate selection depends on the temperature management, surgical requirements and the organ perfusion needs. So the lactate production should be avoided by the perfusionist while going on bypass. So how will you maintain an oxygen delivery during cardiopulmonary bypass? Actually yes, it depends upon the flows. So if you give a proper flows with the proper hemoglobin level and saturation, you can maintain a proper indexed oxygen delivery. So the pump flow is directly influenced by the oxygen delivering capacity, and oxygen carrying capacity of the blood can be affected by the hemoglobin if it is reduced, and arterial oxygen saturation should be maintained more than 100%, and the target that is approximately 100%. The target indexed oxygen delivery will be more than 250 ml per minute per meter square or for adequate perfusion in the adults. So maintaining these parameters is also an essential factor for giving a proper oxygen supply to the patient. So CPB circuit organization will be like blood collection, oxygenation and the blood returning. You are collecting the blood from the venous drainage cannula, reservoir and to the pump. You are giving an oxygen, you are removing the carbon dioxide, and finally you are giving oxygenated blood from the arterial cannula to the patient. So the flow pressure independence. So here we are talking about a critical CPB principle that normal physiology, the flow pressure are independent during bypass. Why? Because it was already taken by the machine. So the increased MAP does not automatically increase the organ perfusion. It can either causes an irregular damage to the circuit as well as the patient's blood vessels. Adequate pump flow is essential for maintaining a proper tissue oxygenation. Kidney perfusion can be primarily depend on the pump flow rates. Cerebral perfusion is influenced by pressure and the partial pressure of CO2. So maintaining a partial pressure and a mean arterial pressure of more than 70 mm Hg will give an adequate organ production. The testing parameters are maintain MAP, maintain the central venous pressure and the pump flow rates. And you can also maintain the partial pressure of oxygen, CO2 and the saturation levels in the gas exchange. You can check the ABGs. The systemic oxygen uptake, that is how much of oxygen has been taken over by the tissues and how much has been released. It depends on the arterial venous oxygen differences, which reflects the tissue oxygen extraction, which you can see amount of oxygen that had been consumed by the tissues. So the test and electric part is our goal is to maintain an organ without getting any ischemia. You want to maintain a good blood flow to the kidneys, so you maintain a mean arterial pressure of more than 70 mm Hg. Cerebral auto-regulation should not be affected because of our bypass technique, and inflammatory responses should be reduced with using a lower flow velocities. Embolic load or a red blood cell trauma should not be occurring on bypass with high velocity flows. So the summary part actually I am defining here is understand the surgical requirements, establish a pressure flow relationship and physiologies, identify the flow rates and depend upon it, and maintain the parameters according to the necessary needed to monitor the proper perfusion during bypass. Thank you for listening. Hope you have understood this topic.